I wanted you to learn in this class was the go-between formula. Now, just so you know, I'm going to write this and see if you like it. The forwards go-between formula.
Love it.
Love it already? Okay. This is the forwards go-between formula. Nope. You oversee. That's what the forwards one is. That's if you have X scores and you're transferring them to Z scores. Now, you can use the exact same one for a backwards problem, but a lot of students figure this out pretty quickly. It's easier to solve this for X. Algebraically. So here's a little tiny bit of algebra, 30 seconds of algebra. If you don't like it, that's totally fine, you can ignore it. But if you solve this for X, multiply this over here and then add mu, you get X equals mu plus Z sigma. And the reason why a lot of students like this one better is because it gets you exactly what you need based on what you have. A lot of times in algebra, you probably remember this from your algebra classes, it's so much nicer when the independent variable is by itself on one side. And everything you have is on this side, you just plug it all in and then out pops what you need. So you can totally use this one to get this job done, but you're going to have that number and that number and then you got to solve in there to get the X value. A lot of students prefer to just do it this way. And this is one of those reference points. It's going to keep us on the back burner when you take 244 because you'll be using it quite a bit. And then you know this. This is 266. That you just found is negative 1.64. And that's 16 days. So all we got to do for this one, put these ideas together. The number of days, now let's put X. Let's call it X. Is the average 266 plus, now it's a negative 1.64. And why is it negative, remind me?
Below average.
It's less than average. It's below average. So you're taking days away from the average of 266, which you should be doing. A 266 is not a preemie birth. It's a normal birth. It's purely an average birth, right? So you have to take days away. That's what the negative 1.64 does. And you have to weight it with the 16, which is the standard deviation that I keep seeing in the journals. So that's about 24-ish, somewhere in there. I'm going to let you guys get more precision for me. So 266 minus, I'm going to call that 24, it's probably more like 25. What do you end up with?
229.74.
239 point, so why don't we call that 240? How about we call that 240? 240 days. That's the cutoff, according to this model. Now, you have to realize something. It's based on three things. It's assuming the average is 266. It's assuming the standard deviation is 16, and it's assuming the definition of 5th percentile. Assuming those three things, that's the cutoff date. What is that in weeks? Divide that by 7, please, if you guys don't mind. 34! Approximately 34. Okay. You heard 37? Which means one of a number of things. Number one, it might be a higher percentile they're using. Possibly. Possibly. Number two, they could be using a different standard deviation.
That's interesting.
It is interesting, isn't it?
My son was barely 36, and he was premature. But he was like not quite 18 inches long.
So that's another definition, isn't
My
it?
daughter was born at 37 weeks, 7/13, and she was.
And you see how Michelle's going like this, which I love?
Yeah.
What are we measuring? This is purely measuring time in the oven.
Yeah.
You're talking about length of the oven. It's a different measurement, isn't it?
Right.
Right? And not to mention the fact that 266 means you know without exception when day 0 was. Which you don't, do you? Now some of you are like, what are you talking about day 0? If you ever have a child, you'll understand this. To figure out what your due date is, you have to reverse engineer when conception was. Well, that's sometimes tricky. You think back and like, oh, it could have been this day, could have been that day, could have been that day. You don't know exactly when that is, right? I'm not trying to be PG here, but I mean, there's some question as to where they sit. Maybe I'll just stop talking now. But the idea is, I'm gonna stop talking. Let's leave it at that. Sorry, turn it red. Push the best together, is that what you said? I don't know. Don't worry. So anyway, there's tons of variability that are being ignored in this model. So now the thing about it is, Michelle, it's not off that much from what you were told. The thing that blows my mind is the 16 weeks. That does blow me away. No, 16 days. The 2 weeks of variability. That's a long time. Yeah, that's a month.
They say 1 day.
That's a month, right?
Well, is that why that's probably why they say it's normal, like it's accepted if you go 2 weeks prior to your due date.
Or 2 weeks after, right? So what they're saying acceptable is 1 standard deviation. 2 weeks prior, 2 weeks after. 16 is close to 14, right? So that's what they're saying. Now, these numbers have come from actual measured pregnancies. So in other words, assuming the mother says this is day 0, they then record when the baby is born. That's a data point. Next mother, here's day 0, here's the baby born. That's a second data point. Once you get a few thousand of those, you average them together, and that's where 266 came from. So if you get a different sample, you're going to have slightly different values, right? But they call them mu. They call them mu because they sampled so many, and we see enough similarity from population to population. There is some variability built in, of course, and the 16 is just kind of crazy. Now let's go on the other side of the coin, which is the pregnancies that go too long, okay? Let's go to that one now. And when I was